external RAM, it is also support up to 64 KB, right? So that was the memory mapping available in the 8051. You see here, it is the only only dealing with the RAM and ROM. The RAM, it is the special function register, that is the SFR in the sense, that is the special function register. It can support up to 22 functions. Okay, it can support up to 22 function that I mentioned here. It is special register. It's up to, it can support up to 22 functions. That is the special function register. That it will be the RAM. That it can be used for the execution of the program. Runtime it may use. Okay, while you are running the program, this all used. This SFR block is used. While you are storing the program, this ROM will be used. Okay, this is the memory management or memory mapping of the 8051. Okay, while if they are asking any questions to explain the memory mapping of the 8051, you need to write the 64 KB internal, external, and the 64 KB how it is split. The 4 KB is the internal ROM, again 60 KB is the external ROM. It can expand up to 60 KB. So apart from that, you can expand the memory again 64 KB. Okay, that was the overall memory mapping or overall memory possibility available in the 8051. That is the memory mapping of 8051. Okay, so the continuation of that, the addressing modes of the 8051. That is the addressing modes of the 8051 microcontroller. So the addressing modes, in the sense, it's a need for writing the coding or instruction to transfer the data or transfer the signal from one block to another block. In the one block, in the sense, you are giving the signal for the microcontroller that it can be processed. So it needs to be transfer the signal. Whatever input you are giving in the keyboard, that input it should be reached to the CPU and it can be performed and it will be produced the required output. Okay. For that purpose, it's need for the addressing modes. Without the addressing modes, we can't communicate the signals from one block to another block. Okay, if you want to travel from one location to another location, you need the location name. For suppose if you are traveling from Salem to Trichy, you must know the source and the destination location. Then only you can book the ticket, right? Likewise, here also you need to give the input from one end, that is the user defined, then required output. For that purpose, the addressing mode plays a major role to transfer the data, signal or instruction from input to output. Okay, input to processing unit, then processing unit to output. Okay, for that, this different addressing mode we are using. For example, the immediate addressing modes, register addressing mode, direct addressing mode, indirect addressing mode, then indexed addressing mode, big addressing mode, absolute addressing mode, right? For this all addressing modes currently we are using, but sometimes it may majorly classified the first 4 that was majorly used in many coding. Okay, then indexed and bit and absolute they are using for some special technical application only. They are using this addressing mode for writing the program. But this was the basic addressing mode: immediate, register, direct and indirect addressing mode. Okay, if immediate addressing mode means you all know transfer the data from one block to another block or one register to another register, right? Immediate means the process has been taken immediately. Okay, for example, I want to move the data. The data is 25H. Data may be anything. Okay, 03 or 05 or 138, whatever data. That is the example data. This data I need to move immediately to the accumulator. That is the A register. Okay, if I want to move the data immediately, I can use the instruction that is the move A, that is the accumulator, the data value. So if I return the instruction like this, the 25H it can be immediately moved to the accumulator. That is why the name is immediate addressing mode, right? That movement is taken immediately. Similarly, the register addressing mode, here I want to move the data from register to accumulator. The R2 is the register. From the R2 register, whatever the data is already stored, that can be immediately moved to the accumulator. So you are moving the register to accumulator. That is why the name is register addressing mode. You have to write elaborately and write the example. Then direct addressing mode. The direct addressing mode is also the same. The direct data. You see here that 30H is the direct data. That data can be directly given to the accumulator. Any data or any signal, it can be transferred immediately or directly to the register. So that is the direct addressing mode. Indirect addressing mode in the sense, so indirectly the data has been transferred, right? That is the move X A. That is the R A. The A is indicating the A register. Okay, A register. It's have the memory capacity up to 8 bit. So here the R0 is the register. So from the R0 we are moving the data from the register into A. Why we are saying the indirectly? Because the R0 and R1 register, it have stored some data. That data has been communicated indirectly through the option of X. So indirectly we are getting the data. So while you are moving this data, right here, what is the difference between move X and move A? You see, and move data. Here the data is directly transferred, and in this data you are giving the input. While you are giving the input itself, you can give it directly. This is from R2 register to move A accumulator. This is also the data, that is the address location. While you are putting the R symbol, that is the address location. But while you are putting the so the data is not moved permanently to the accumulator. Okay, the data is indirectly, means it can be copied. Okay, it can be copied and it can be here it may saved, but if you want to access again the data, the R2 register, whatever the data it's have, it is after moving here, it may available for further communication. Okay, if I want to, I have already stored the data in the R0 register like 30H. Okay, if I want to move, you can use this command. This command. Right? If I want to use some other applications or other instruction also, I put R in front of R0. So the R0 data is not permanently moved, it can be copied. So that is for the indirect addressing mode. That is why the name is indirect addressing mode. Then indexed addressing mode. Indexed addressing mode means if I have, you see here, the R0 is already have the data. If I want to add somewhat value, right? Somewhat value, that is the 5. Or 10 or any signal I want to make addition, so you can give the at R0 already the whatever data is available in the R0 register, it can be called, it can be moved with addition of 5. That is the indexed addressing mode. Indexed addressing mode means you need to combine or you can manipulate as per your requirement. You can manipulate any logical functions and R0, whatever it is. Then bit addressing mode means that is bit addressing mode, it is used for the ports. Okay, in the microcontroller architecture you may see 4 ports, P0, P1, P2, P3. Okay, here you are setting the bit, that is the bit from 1 to 2, from 2 to 1. It means here you are moving the data. Here you see, here all are, it is data is moved from the register to register or memory to register or accumulator, that all the memory. But here the signal, it may transferred from port 2 to 1. For that we are using this addressing mode, that is the bit addressing mode. Then absolute addressing mode in the sense, your data pointer register here. Okay, here also that is the register. So here whatever the data we header files are, whatever the data we have the pointer, so that has been communicated for based on our requirement. That is the absolute addressing mode. Right? These are the different types of addressing modes are there in the microcontroller that we are using in the for the any programming or any realistic application. We may use this all. So these are the instructions, that is the assembly language programming. While we are writing the assembly language programming, that instruction also you may that was the single instruction I taken for common reference. But while you are writing the program, these all addressing modes we can use it for the specific applications. Right? These are the different types of addressing modes we discussed, and this is the memory mapping of the 8051 microcontroller. If you have any doubt, you may ask. Okay, thank you.